Good afternoon, everyone. We're just gonna start in a moment. We'll give it about 30 seconds to a minute until everyone is that registered is joined in before we start. All right. Yeah, we have quite a lot to cover today. So we're gonna start on time, make sure we finish on time. Good afternoon, everyone. My name is Amin Menena. I'm the Technical Services Coordinator at the Municipal Engineers Association. And I'll be your moderator today for the webinar, coordinated by the MEA's Climate Change Committee. And it's on existing building decarbonization strategies. Our presenters today are from Quasar Consulting. Our first presenter is Eric Dunford. Eric is the ESG lead at Quasar Consulting based in Toronto. Eric is a skilled sustainable design specialist and facilitator. Eric works with stakeholders to guide and support design professionals in charting effective and cost-efficient approaches to emission reductions for existing buildings. We're also joined in by Alexandra Onisko. Alexandra is the building performance lead at Quasar Consulting, based in Toronto. Alexandra is a professional engineer with more than a decade of experience in energy modeling, pioneering some of the first net zero decarbonization studies conducted for public sector facilities in Canada. And without taking more time from our presenters, Eric, the floor is yours.
Excellent. Well, thank you, Amin, for the introduction, and thank you, everybody, for joining us today. So we have a lot to go through today, but before we do, I'll just cover a couple of housekeeping items. So you will note that you are on mute. I do encourage you throughout the presentation, if you have any comments or questions on anything that's presented, please feel free to add those either in the Q&A box or just in the chat function. We'll make sure to cover those towards the end of the presentation, but do feel free to put those in whenever they come to you. Note as well that this presentation is being recorded, so there will be a copy of the slides and the recording itself that will be available after today. And again, I've already covered this, but for Q&A, we'll spend some time towards the end of the session today to cover any questions that come up. So the agenda today, we're going to cover a lot. This is going to be dense, so stay with us, but we're going to be going through a lot of the current kind of art and science around decarbonizing existing buildings. You can see here the list of things we're going to be tackling. First, looking at the background, then talking about some of the terminology, talking through a little bit some of the reasons why cities are focusing on this topic, going through the approach and methodology and best practices. We'll share a few case studies, talk a little bit about barriers, and then finally talk about some actionable things for you in terms of funding sources or resources that might be helpful if you're considering this for your municipality. I'm going to skip the intros. Here's our pictures, but you already heard our intros, so there's no need for us to go through that again. But happy to be here with Alexandra, who I work closely with. And again, there's lots to cover here, so let's get right into it. So first, why is this important? Well, in Canada, buildings continue to be a very significant source of emissions. If you look at nationally, we're looking at about 13% of overall emissions. I would say that Canada has kind of a disproportionate percentage here, that it's smaller than it is in other countries, and that is due to our larger oil and gas sector, which you can see at the upper right-hand side. So this number is seemingly smaller than it actually is in impact for other nations. Also, when you look at buildings, where the emissions are rising from, they're coming mostly from heating requirements. We are a cold country, surprising nobody. Depending where you're joining from today, you can understand that heating requirements are the primary source of emissions from our buildings. And that's just shown here in this graphic. So you can see here at the bottom, we're looking at the actual energy consumption. And at the top where it says emissions, that's the impact of that consumption on the overall GHGs that are released into the atmosphere. So you can see here that at the bottom, the energy consumption for heating is lower than its emissions impact. And that is because things like natural gas, fuel oil, other things like that have a greater impact on emissions per unit than things like our electricity grid. So it's a smaller percentage by total consumption, but it's a very great percentage in terms of the emissions impact. Other emission sources are things like lighting, electricity plugs that are being used for various electronics, elevators, cooling, pumps, space heating, electricity that is used, so like baseboard heaters, those sorts of things, fans, other items like that. But really when we talk about sources of energy emissions in buildings, we're really talking mostly about heating, lighting, and other plug loads. So the good news is here, we are getting better at designing buildings. We are doing a better job of tackling emissions and making more environmentally friendly buildings. I wasn't able to find a very good Canadian source, so what I'm showing you here is actually an American source. But this organization, Architecture 2030, looked at about 15 years worth of data in terms of building construction in the United States. And what they found is that over that time, the total square footage of buildings in the built environment increased by 47 billion square feet, which is the blue line, or an 18% growth. At the same time, energy consumption remained effectively flat at around 1.7% below where it was in 2005. But most importantly, you can see that emissions trend for buildings and the CO2 emissions at the bottom in the gray, where over that time, despite that growth, there was actually a reduction of about 21% in the actual carbon emissions impact. Most of that is stemming from greener electricity grids, retiring of coal power plants, greener sources of energy, but also the fact that now as professionals in the architecture and engineering space, we think a lot about sustainability, where before that wasn't really a primary driver. So if you think about 2005, things like LEED were really just getting off the ground. And over the past 20 years or so, we've seen a very big explosion in the science and the art of designing better buildings. So that's a good thing. From a policy perspective, I mean, all of you on the line are joining from municipalities, so this is probably a world that you are living in far more often than we are. But when we look across the board, we are also seeing a corresponding increased focus on emissions reduction. So in Canada, we have a federal target for net zero emissions nationally by 2050, and we have an interim target for 2030 that is targeting a 40% reduction. You can see that graphic here, which is coming from the federal government. And there are a number of different items in play that are pushing our overall economy towards that lower carbon future. Probably the most important, probably the most painful is the carbon pricing regime that has been implemented. And as you may or may not know, we currently do have a carbon pricing scheme in Canada that is national. And the numbers that are being affixed to a ton of carbon are scheduled to rise very rapidly between now and 2030. So this is the law of the land. And for provinces that don't have coverage of all emission sources, the federal program does backstop or maintain and enforce that requirement regardless. So all provinces in Canada are subject to this, and it is affecting a lot of innovation. It's affecting a lot of decision making as that price of carbon starts to rise very rapidly. Provincially, we're looking at a couple of things that are more about what I'll call the mechanical side of this, in the sense that we're looking at regulations that require public agencies to report on energy consumption and to disclose that information publicly. So there are two regulations listed here that really focus on requiring public entities to talk about their emissions and energy consumption in a public way, and to talk about strategies or programs that are being developed and utilized in order to pursue reductions over time. And again, my sense is many of you on the call will be very familiar with these items, as they may be part of the roles that you are playing at local government. And finally, this is currently an interesting political dimension in Ontario, but I think very importantly, we are also seeing different cities are deploying their own green standards or carbon emissions reductions targets for all of the buildings that are in their jurisdiction. So the most kind of established, most well-known of these are in Toronto and Vancouver. Toronto is obviously more relevant for us here in Ontario, but City of Toronto has established a goal of 2028 for new buildings to be designed without any emissions whatsoever. And 2040 is the target year for all existing buildings to reach zero carbon performance. So that is a huge target. That is a huge number of buildings. That is a huge ambition. And unfortunately, that ambition is being driven by the reality and the recognition that we are very far behind on where we need to be on the climate based off of climate science. So this is ambitious and aggressive, but it is also necessary. And that is what is really pushing, I think, a lot of these standards developments and changing the way that municipalities do business. Unfortunately, here in Ontario, we have an added challenge in that we have long relied on our power grid to be low carbon and to provide us plentiful energy at a low impact from an emissions perspective. What we are expecting in the future is that our power grid in Ontario is actually going to become more emissions intensive. And that is because we have disruptions with nuclear facilities that need to be renovated or retrofitted or just expanded upon. And we are going to be forced to rely more on things like natural gas as a stopgap in this time. So that's just something to be aware of, is that the ground is shifting underneath us a little bit here in the sense that the electricity grid is also changing. So I'm going to pass it over to Alexander to talk us through a little bit about some of the tips and tricks and the terminology here when we talk about net zero.
Thanks, Eric. Okay, so before we start talking about decarbonizing our buildings, it's very important to get agreement and understanding on the terminology that is used in the industry. So I will go through some of the terms and definitions that we have, so we have a common language that we're speaking to. The first term that I wanted to discuss is greenhouse gas intensity, or GHGI. So essentially, GHGI is a reflection of how emissions intense your building is. It's a combination of two factors. So how much energy your building is consuming, but also what fuels are being used to meet those energy needs. As Eric alluded to, our grid is very clean in Ontario, so the more electricity we are using, the lower emissions our building is, and the more gas we are using, the higher our GHGI will be. The second term that we wanted to talk about is the total energy use intensity, or the TEUI, EUI. It's referred to in different ways across industry. But this metric is the most universal out of the three that we're talking about. It is the one that you will be using for benchmarking. So if you're looking to compare your building to similar buildings in similar climate, this is the metric that you use. It's a reflection of how much total energy your building is using over the course of the year, divided by the area of the building. And it's a great metric because it includes every single end use, such as space heating, pumps, cooling, plugs, any renewables you have. But it also means that you can take credit for reductions in every one of these categories. The last metric that we wanted to mention is the TEDI, so the thermal energy demand intensity. The TEDI is a little bit more new, and it's really been widely used in Vancouver as well as the City of Toronto, and it's a reflection of the heating demand that your building has. It's a reflection of two things, essentially: how efficient or inefficient your building envelope is. So the more heat loss you have, the less efficient your building envelope is, the higher your TEDI, because you're increasing the demand for heating. And the second item that it reflects is the ventilation in your project. How much ventilation you have, are you recovering it, are you controlling it, and so on. And it's an interesting metric to balance with air quality and occupant comfort. As we know, more ventilation is great for air quality and things such as infection prevention. However, it does increase your TEDI if you're not treating it. Okay, so before we get into decarbonizing our building, let's talk about what the different net zero carbon, net zero energy terms mean as well. So often you sort of hear net zero used interchangeably, and it's difficult to tell without context what that is referring to. So let's talk about some of the ones that are most frequently used in the industry. So let's start with the most stringent metric. So a net zero energy building. This one is, you will not see too many of these around, but a net zero energy building is consuming as much energy over the course of the year as it is able to produce on site through renewables for the particular project. Now we have a net zero emissions building or a net zero carbon building. This one is gaining a lot of popularity. And when you hear net zero in the context of municipal buildings and other projects in Canada, this is typically the standard that is being referred to. So a net zero emissions or carbon building is a very efficient building that, to start off with low carbon factor associated with it. But the building also produces either on-site or procures carbon-free renewables off-site to offset the annual carbon emissions. So you can think of it, you may be producing some energy on-site to offset your consumption, but if you can't produce it all on-site, for this context, it's okay. You can offset that through purchases. And the third definition is net zero. So this one is a little bit more loose, but it is essentially still a very energy efficient building, but for whatever reason, it cannot reach net zero energy or net zero carbon, but it can with a future transition plan. And that future transition plan can look like eliminating all gas-fired appliances from the building, or it can look like installing some solar panels or other renewables on site just to get to those other targets. So the most frequent standard that is used for evaluating net zero carbon buildings in Canada is the one published by the CEG. And the core of that standard is the achievement of a net zero balance. So this means that the net zero emissions for the building, however you balance it, will have to be zero. And this includes anything from embodied carbon, so your upfront carbon, all the carbon that's involved in the manufacture, construction, and decommissioning of your building. Your operational carbon, so that you can think of that as your utility bills, and that includes your direct as well as indirect emissions, minus any avoided emissions. So again, anything you're producing on site, as well as anything you're procuring off site to achieve that net zero balance. And I'll turn it over to Eric to talk about some of the rationale for action.
Great, thanks, Alexandra. And yeah, as you can see, net zero means a lot of things. So being very specific here, what we're going to talk about today is net zero carbon buildings. So as Alexandra said, you can imagine trying to supply all the energy on a site is difficult if your facility is large or if it has a very significant power draw. So we're really here talking about net zero carbon, not net zero energy, though that is a very valid and important topic as well. But let's turn our attention here a little bit to, why is it important for cities to act on existing buildings? Well, one, as you will likely know, when you look at the general assets that cities have, their primary sphere of influence is going to be around operations that cities control. So we often hear these called like corporate facilities, corporate buildings, corporately owned. And what that means is these are the buildings that a city actually has under its control and ownership. So think about things like libraries, think about things like City Hall, maybe community centers, recreation centers, parks, those sorts of things. These are assets that the city really controls without a lot of other stakeholders involved. Now, this makes them really good targets for climate action because you can do things on your own without permission from others, without necessarily disrupting or having to consult stakeholders. And that's really important. So municipal services really here are a key target for action to be taken that can be taken quickly and can be done, efficiently today. When we look at other things like, community planning or long-term growth and regional planning and those sorts of things, like how do we design a community or a neighborhood? Those are much more complex. They're very important and I would argue more impactful to target, but they have a lot of stakeholders involved. There are a lot of rules, there's legalities and agreements and things like that. So when we talk about land use or transportation, they just involve a lot more players and can be a bit more slow moving. So existing buildings are really critical for cities to start with because they offer a really rich target for emissions reductions. And they offer a good learning opportunity and environment where you can start to look at developing capacity internally. The other good thing about existing buildings that cities control is they typically have very good records because cities keep good records of how their facilities are maintained, what kind of energy consumption they have. So when we look at strategies for potentially decarbonizing them, all of that rich data is on hand and available for professionals to look through and to advise on. The private sector outside of all of this is much harder to influence, as we all know. So we're really focusing today again on the municipal sphere and where effort can be best applied. And this is really important because I want everybody to understand one thing here is that most buildings that will need to be decarbonized exist today, right? So if we talk about net zero by 2050, most of our challenge, most of our problem is already in the ground. It is the buildings that are drawing power, that are burning natural gas today. And what a lot of studies have shown is that even if we were to switch over to net zero new construction for all buildings, as you saw with the city of Toronto targeting 2028 for that, it's not going to do enough to decarbonize the overall building stock. We have to do this for existing buildings. And in British Columbia, they did a study where they looked at, what the impact of their stricter building code requirements would be for new buildings. And they found that even with these very strict new programs coming into place that would govern construction of all of these new buildings that are going to be built in that province, they might only achieve about a third of the overall reductions that they need to achieve in the building sector. Or to put it another way, if we look at the existing building stock, we need to be decarbonizing about 3% of the overall stock each year, every year between now and 2050. And you can see here in the figure, they're giving you figures from British Columbia, but they're projecting for ICI, institutional, commercial industrial facilities. That's about 1,800 buildings per year in British Columbia. So for Ontario, we're probably about triple that amount because our population is 3 to 4 times larger. So if you think about it that way, like we have a lot of work to do, and the magnitude of this scale, you can see why it's really important to start this work as soon as possible, because it's very easy for us to fall behind with that kind of pace that's required. And the other thing here is that, as the public entities, the public sector does have an interesting role to play as somebody who is setting the example again. So we want to talk about influencing the private sector or the community. Public buildings are very high profile. They are accessible to all, and they are representations of kind of community values and overall policy objectives. So these buildings, because of being highly visible, being accessible to many, their performance can set a very important standard for other parts of the community and other developers or other property owners. And this is far outstrips the percentage of their contribution. So you can see here, I'm showing you a figure from the city of Brampton, where they're reporting that of their total community emissions, institutional facilities, and that will include things like school boards, only account for 2% of the overall emissions. But that's not to say, again, that action in this space is not very influential because it can incentivize or inspire action on the part of others as well. So that's really, again, what we're here to talk about and why we see this as such an important part of municipal action. So Alexandra, why don't you walk us through the actual methodology? We've talked a lot about the why and the what and the terms. Let's walk through what this actually looks like in practice.
Yeah, absolutely. So the task of decarbonizing a building may seem daunting, particularly if you're looking at a portfolio of buildings and you're trying to establish a strategy and sort of a roadmap for how you will approach this. So we've identified 6 key steps that are generally taken when we are looking to decarbonize a portfolio or a group of buildings. The number 1 step is to determine which buildings we need to focus on. So assessing your portfolio. Different buildings in your portfolio may have very different emissions. You may find that 80% of your emissions are actually coming from only a handful of buildings. So that analysis will provide you a lot of information and give you the tools to make your decisions in the next steps. So once you identify your high priority buildings through this assessing of the portfolio, it's very important to start building a business case for these retrofits and decarbonization strategies. So we'll talk a little bit more about that in the next few slides, but let's just cover the rest of the process. The next step is typically studying the options. So once you've identified your building, you've sold the business case to the stakeholders that need to be sold on it, we're figuring out, okay, what are we actually going to do? So typically consultants are engaged and brought in, mechanical, electrical, architectural, sustainability consultants, and they are assessing the different options that you have for the decarbonization strategy. Every single building is unique. There's some common ground strategies that will be similar for a lot of the building stock out there. However, the approach to decarbonization will look different for every single building based on the systems that we have, your capital planning for the project, your occupants, what you're planning to do as well for the use of the building. Maybe it'll change, maybe it won't change. So that will inform the decisions that you will have for actually implementing the decarbonization plan. The fourth step, and not to be overlooked, is of course securing financing. All of these measures that for decarbonization, they will cost money. And that will range depending on the speed at which you're implementing these, and also the sort of the gap that you have to fill. If you're starting with a very low performing building, the gap to decarbonize building will be much higher than if you're starting with a building that's already doing really well. So securing financing can look like a lot of things for different projects. It could be loans, grants, it could be a combination of the two, but it is very important. And the fifth step, and this is sort of disproportional in terms of the impact, they're all equally looking here, but implementing the capital project. So that will be the biggest portion of the activity for a decarbonization process. And I say this because it will either be a process that takes small steps over time. You may be looking at your decarbonization strategy over a 10, 15-year period, or you may be doing it all at once, in which case it is a very onerous and sort of big undertaking at one time. So that is sort of the meat of the decarbonization strategy. And of course, not to be missed is monitoring and verification. So we want to make sure that what we think we are achieving, we actually are achieving. And Eric mentioned some reporting that guidelines that are out there, some requirements for public buildings to report. So that goes hand in hand with this. We want to make sure that once we've done all of this work, that work is showing results. We want to make sure that we are meeting our targets, and if we're not meeting our targets, we can figure out why we are not meeting them, and then we can of course address them and get the building to where it needs to be. So let's talk about, have a sideline sort of about building the business case for decarbonization. What that business case will look like will be very different on the building. And again, it will depend on the particular project. One of the items that we see coming up a lot is making sure that the plan fits in with your capital plan. So let's say you have commitments, you have made commitments to upgrade certain equipment that is coming to end of life. You have made commitments to certain maintenance activities, whether it's mechanical systems, envelope systems, and maybe you're doing a complete refit on the building. That can play a part in establishing a business case for a decarbonization strategy, because those things can go hand in hand. The other item that's also very important to do when establishing this is to have a building condition assessment and an energy audit. We generally recommend starting with an ASHRAE Level 2 audit as a minimum, and this serves to establish our base case. So it's before we proceed with any planning activities, we need to know where we are. Is our building efficient? Is it non-efficient? Is the gap to complete carbon neutrality very large, or is it very small? And are there any low-cost opportunities that we can identify that we can action on before we move into a full decarbonization strategy that may be a little bit more onerous? So doing things such as the building condition assessment and audits, as well as utility analysis, will help us establish that. The other aspect is also looking at the funding opportunities out there. And this may influence your decision and the actions that you take for your particular building. So I would say right now, we're in a very good funding environment for decarbonization buildings. The government has said this is a priority. They have also allocated funding to help municipalities and even private buildings to move us towards that goal. So right now, there's quite a bit of funding available. This will not always be the case as we move closer to that 2050 carbon neutral deadline. But again, funding is a very important part of building the business case for this. Okay, so let's talk about what a study looks like, because again, this is a very important part of a decarbonization strategy. It really gives you the roadmap of what actions you have to take, when you have to take those actions, as well as how much those actions will cost for your particular building. So in every single study that is undertaken, it's very important to establish the goals. The goals may be different based on your particular project. It may be different based on the municipality. It may be different based on the particular use of the building. There's different priorities that have to be weighed, but starting with a common set of goals for the project is essential in any decarbonization study. The second step is making sure you understand the building in detail. So that can look like site visits, extensive document reviews, interviewing the operators, interviewing the stakeholders for the building, as well as the occupants. And that will all be taken by your sustainability consultants, and they will develop essentially a digital twin of your particular project. And your project can be either a single building or it can be a group of buildings. And what is done in that case when we're creating a digital twin is essentially a calibrated energy model that reflects how your building is built, how your building is operating, the various efficiencies that you have in your building. So it's a representation of what you're working with. Out of that, what we typically see is the establishment of some energy conservation measures. So energy conservation measures are steps that you can take to improve the performance of your building. And they really can range in terms of both complexity as well as cost, from something such as optimizing your heating controls or your temperature set points in your mechanical systems, or it can look like a full building envelope retrofit or complete mechanical system replacement. Once these energy conservation measures are established, these are then analyzed. So when we're using a digital twin of your building, then we take those energy conservation measures and say, okay, if we apply this, what is the result? What is the result on our energy use? What is the result on our carbon intensity? And what does it mean for our cost as well? So typically we are working with cost consultants in conjunction with this, because each of these measures will have a cost associated with it, both in terms of initial cost, maintenance cost that is different from the system that you currently have, as well as replacement costs. So all of this is taken into consideration, and life cycle costing of each measure is developed. And it's very important to use life cycle costing as opposed to initial capital investment, because we want to understand and know what the cost of this particular measure or strategy is over the whole project life, so we can do an apples to apples comparison. As sort of an example or an anecdote to illustrate this, you may have a system that will be let's say double the price of an alternative system initially. But if that system needs to be replaced 2 or 3 times during the project life cycle, the cost of that will be very different. And if you're comparing only the initial cost versus the total life cycle cost. So it's very important to keep that in mind. And out of this study, typically what we will have as a result is a recommended strategy for the building. And that may be a single strategy if you've established a very set goal, or it may be, maybe 3 options for strategy. Maybe you want to see sort of the lowest life cycle cost option. Maybe you want to see the lowest carbon option, or maybe you want to see an option that gives you the most carbon reduction possible for your particular site. So these options are then presented and taken away by the stakeholders and then decision makers, and then make decisions to what to do next. Next slide, please.
Sure, I was going to say, I know the term digital twin, Alexandra, I just wanted to say, to me, it always reminds me, I'll date myself with this reference, but it's almost like the SimCity version, where again, we're taking the building and we're basically making like a virtual model that you can play around with. So you can take the building as it stands today and then look at, what if we change this? And as you can start to imagine here, right, when you look at all the different building systems that could possibly be in play, there may be dozens or hundreds of potential configurations that if you change one will influence the others. I think that's one of the most fascinating parts of this whole approach, is that you can really look at what's the kind of best combination that might take my existing structure and turn it into something that's much greener. And then, as Alexandra was saying, like at what cost, at what pace, what makes sense, and kind of scheduling that out. I think that's really kind of the magic in all of this from the study side, is the capacity to look at what is and then look at what could be based off of changing a bunch of dials on that model, which is really cool to see.
Exactly. That's absolutely right, Eric. So as I mentioned, the strategy that you will have for decarbonizing a project will look very different based on the project that you have, the particular constraints in terms of budget and other operational issues that you may have. However, the process of how we get to the strategy looks very similar from project to project. So we like to talk about this net zero pyramid. And the reason we like to call it a pyramid is because we have, Our most important measures at the bottom, and this really forms the basis of our entire process. And then as we progress along the pyramid, the influence of these different strategies becomes less and less. So really we need to focus on the bottom. So starting with reducing our loads through passive strategies. Would you advance the slide, please? Thank you. So reducing the loads through passive strategies is the #1 biggest influence that you can have on your project. This should be the basis of every single decarbonization project that you have, and it will look different depending on what you have in your building. So the #1 method to reduce that is to address your massing, which may not be possible if you have an existing building because it's already in place. Things such as orientation, building shape, the site that you have, you may not have influenced that for an existing project. However, for new construction, this is something that is of paramount consideration when we're establishing our approach. However, things that you can influence in an existing building is your building envelope. So the way that we reduce loads through the building envelope is to insulate it more, have better thermal bridges, and to make sure that we are addressing any infiltration issues so that our building and mechanical system does not have to meet a ridiculously high building load because we have not addressed the #1 item that is of importance, which is our building envelope that we have. Next slide, please. Yes. So I mentioned insulating, which I think, you know, when you're thinking about the building envelope, this is the #1 item that people think about. They want to think about adding more and more insulation. However, that is only one portion and one aspect of thermal performance of the building. And the other aspect that has been frequently ignored is the thermal bridging effect. So you may look at a wall and, you know, you may hear that it has an R value of 20 or 30 or 40. So when people mention those values, those are typically nominal insulating values. So that's essentially you put in some bad insulation, some rigid insulation in there, and that's sort of, if it existed in isolation, that's the value that would have. Unfortunately, this is not what our building envelope looks like in real life. We have many interruptions to the insulating layer in the real building. Things such as studs, you have your fasteners that are attaching your cladding systems, you have sort of breaks and insulation and all of these linear interfaces such as your window wall transition, your balconies, your slab edges, your parapets. All of these are opportunities for energy to escape your building because we have a discontinuity of insulation. So when we are talking about decarbonization strategies, it's important to think about these in conjunction with how much insulation you're putting, but also how you're addressing these thermal bridges. And this is something that your architectural consultant or your building science consultant or your sustainability consultant can help you with. And it doesn't necessarily mean high cost premiums. Sometimes it involves careful detailing of how we are approaching the design. And the other aspect of this as well, you know, other than the thermal performance that we have for our walls, our roofs, and our windows, is also infiltration. So this is often something that's been ignored in the past, and particularly in existing buildings, it is frequently a large source of heating load. So infiltration is essentially the uncontrolled movement of air between the outside and inside of your building. You can think of it as, you know, drafty windows, for example, poor door seals, any infiltration that's coming in through any penetration in your wall, such as your exhaust and so on. So we really want to minimize that. And it's one of those things that ideally it is done when the building is constructed. This is the easiest way to address it. However, when we have an existing building, it is still possible to do quite a bit in terms of mitigating our infiltration for the project. And that can look like, you know, whole building air sealing. It can look like recladding the building in conjunction with adding insulation and so on. So here we have a slide just demonstrating the importance of thermal bridging. As I mentioned, this is something that's been largely ignored prior to you know, this recent push towards decarbonizing our buildings and really reducing our emissions. So here we have a heat flow diagram of a typical wall. I won't get too much into detail in this, but what I want you to pay attention to is these two splits. So our clear wall on the top, where we have our 20% or 21%, is sort of the wall that you would typically consider when you're thinking about your wall. So this is where there's no interruptions, there's no interfaces with any sort of corners, with any windows, no studs and whatnot. This is just your wall in an ideal scenario. So in this particular project example, only 21% of the heat was leaving through that clear wall section. The rest of our heat loss, which is almost 80%, was actually as a result of our thermal bridges. And in this particular building, this was really our balconies. So we were losing a lot of heat through our balconies, and as well as our window perimeters. So this is why it's very important to consider thermal bridges as we are looking at our decarbonization strategy. The second step, after we've reduced our loads to these passive strategies, we've done a lot of work on that end, is to then meet these hopefully much smaller loads with very efficient technologies. So what very efficient technologies looks like for the building will differ based on the loads that you have, but generally it is addressing the active systems in your building, such as your mechanical systems. Typically what we look at is replacing natural gas-fired equipment with heat pumps of all types. So air source, ground source, sun source, we're trying to recover any energy from the outside of the building and bring it inside as much as possible of that. Replacing our domestic hot water with more efficient equipment. So that often means for decarbonization strategies, we are changing our gas-fired equipment out for heat pump systems. Again, same applies air source, ground source, sun source. This also looks like improving our building automation systems and building control systems. So this is very important. As we like to say in the industry, the most efficient system is a system that doesn't run. So if you have the ability to control that within your building, if you have a building that has variable occupancy, if you have rooms that are not occupied all the time, there's opportunities to shut down mechanical systems, electrical systems, other systems in your building to respond to that decrease in load. So there's a lot of opportunity within the controls of our building to gain a lot of efficiency. Reducing lighting energy. So that can look like having more efficient lighting, so LED lighting. Even within LED lighting, there's lots of opportunity for sort of the top tier performance, which means that you're getting the most output in terms of light for each watt of energy that's input into the bulb. You can also look at lighting control strategies, daylight harvesting, extensive occupancy control. Those are some of the strategies that we typically see addressed when we're talking about reducing our lighting energy. Another important aspect is flow control and any sort of demand response that you can put on your system. So that all falls into the category of making sure that the systems that we're using to meet our loads are very efficient. Okay, so one item that we wanted to talk about again is sort of the resources available for, what you can refer to for these technologies. So we've flagged the City of Toronto Net Zero Existing Building Strategy as one resource available that sort of outlines some of the common technologies that are used in decarbonization strategies, as well as identifies the typical impact of these in terms of reducing your carbon, and also the typical costs associated with it. So things like that are really good rules of thumb and quick guidelines to refer on projects when you're looking at suggestions on how to best approach the technology and efficiencies in your building. One item that I would like for you to take away for this presentations is heat pumps, heat pumps, heat pumps. If you remember anything for mechanical systems, this is key. So these technologies, and now, and I do say technologies because they come in different shapes, sizes, forms, and sort of methodologies, depending on building size and application. They have the opportunity to drastically improve your emissions for your building. So the primary method that they do that is, number one, they fuel switch. So instead of using combustion equipment, we are now using, you're not using the methodology of combustion to generate heat. You're essentially taking heat from one source and moving it to another source, and you may be increasing the degree of heat that is. And you're using electricity to do that. So it's sort of two things that you're doing all at once. And the result is that you are having much better performance in terms of energy, as well as carbon, and frequently lower operating costs as well. Okay, so then the next item that we address once we've reduced our loads, we've met all our loads very efficiently, is on-site renewables. And on-site renewables will look different depending on your project. However, I would say that 95% of the projects we work on, it is solar PV. However, now what we're seeing, we're not only seeing solar PV on the roof, but we're also seeing solar PV in parking structures as projects are looking to meet more of their energy needs through on-site renewable generation. We're looking beyond the roof, looking at parking structures and what can be done for that. And also one technology we've seen emerging is building integrated photovoltaics as well. So this is when you're using the vertical surfaces of your walls to generate electricity as well. And that technology has come quite a long way, and it's great to see that picking up in the industry. Other sources of renewables on site are sort of non-traditional ones, such as solar water preheat, solar fresh air preheat, renewable natural gas, which is not widely available depending on your locality, but it is an option for some projects, as well as wind turbines and geothermal systems. And the cherry on top of this pyramid, as we like to say, is our mechanism of last resort. So once you've exhausted all of your strategies from the previous sort of 3 rungs of this pyramid, this is the last one that you will be looking at. And this is the purchase of offsets or credits. So this is a financial commitment that you will be making for the life of the project to essentially meet that net zero carbon balance on an ongoing basis. And there's a few options for this. So you can either purchase offsite renewable energy generation. So you can think of, of the more common ones, such as bullfrog. You can even buy that for your house. So that is an option. There's a few different providers out there that you can purchase this from. You can also pay money in exchange for carbon renewable technology. So you're essentially giving someone funds to invest in a carbon sequestration project somewhere that is not on your site. So that is also an option. Or you can have some forestry projects and other natural carbon sinks. You can think of this as paying someone to plant an acre of forest to offset a certain amount of carbon for your project for that particular year. So there's different options available. One thing they do have in common is it is an increasingly significant financial commitment. We are seeing that the cost of especially quality offsets is increasing as there is increasing demand for it. And the other item is that this is something that is ongoing. So you will have to do this year after year, and the cost of that will increase as we go towards 2050.
And it doesn't solve the problem. You still have the building performance that needs to be solved. So maybe more the lemon on top than the cherry for the offsets.
I like that. Yep. Okay, so that was a lot of material to cover, but what we want you to take away is these best practices. So this is sort of the cheat sheet to decarbonization for any building. Number 1 is reduce your loads through building envelope improvements, more insulation, better thermal bridging, addressing infiltration. Number 2 is implement energy recovery ventilation and demand control ventilation on your fresh air loads. So this plays a part in reducing our loads. We want to make sure that we are addressing our ventilation loads, which are very high in a heating dominated climate. We have to heat every CFM or cubic meter or cubic foot of air that we are bringing into our building. So any way we can reduce that is fantastic. The third item is to implement a low carbon mechanical system. So this is heat pumps, heat pumps, heat pumps. If you remember one thing, this is it. And not to be forgotten is retro and recommissioning of the existing system and commissioning of new systems. So you can implement any system that you would like, and it can be the most energy efficient system. But if it is not operated properly, if it is not balanced properly, is set up properly, your system will not deliver the energy savings that you have. So it is extremely important to recommission and retro-commission any system that is existing, and also to have commissioning on any new system that is being installed. And the last item is, of course, any renewable energy generation that you can put in on site is great. So we wanted to have a little sidebar just on this heat pumps, heat pumps, heat pumps theme. and talk about the different mechanical heat pump systems that you can have in your building. And this is what we're seeing as being very successful in a lot of decarbonization projects that we come across. So heat pumps are a very low carbon system to begin with. There's different options. You can have water source heat pumps. You can have water source heat pumps with geothermal. So essentially you're using some sort of liquid in your build that is circulated in your building, and then you can either extract or reject heat to it on the space level or centrally. We have our variable refrigerant flow or VRF systems, which are also a type of heat pump, and that can be either combined with an air system, so without a hydronic heat source or sink, or it can be a water source heat pump, and that can be combined with low carbon heating and cooling, or it can be combined with the geothermal system. And air source heat pumps is general. So those can either be centralized systems or they can be distributed systems, again, depending on your projects. All of these are excellent options for both new construction and particularly decarbonizing existing buildings. And they will be applicable in one degree or another degree in any strategy that we consider. And the goal is essentially to eliminate natural gas within the building as a whole. This is where we're heading as an industry. Okay, so let's talk about some of these case studies. We talked about, a lot of these sort of abstract and sort of ideas in isolation. So let's see how they all come together in buildings that we have worked on. So the first example that we wanted to speak about is actually a new construction building, but because this is a fairly common municipal archetype of building, we thought it'd be important to talk about how we addressed having a low carbon design for this. So this building that you have on the slide is a fire and training facility in Southern Ontario. So it's a building that provides, emergency response services. It has 3 fire bays for the fire engines. It also has a facility for the firefighters to sleep and receive training, and it has a small administrative office. So this building archetype has in the past been fairly challenging to address in terms of energy efficiency. We have these huge doors that are open a lot of the time. And then we have to heat the space inside that they're open to, and it's been a challenge in past projects. However, for this project, energy efficiency and particularly carbon reduction was identified as a very important goal. And this project was actually pursuing funding through the Federation of Canadian Municipalities program and was successful in obtaining both a loan and a grant under this in recognition of its energy efficiency. So what did we do for this building? Essentially, what we did is use heat pumps. We electrified the building. We used variable refrigerant flow system in the administration area, as well as air source heat pumps in the other areas. And we used extensive energy recovery ventilation. So this all really goes hand in hand with that reducing our load strategy. In this building, fresh air was a very large portion of our energy load. So we made sure to reduce that by introducing a lot of energy recovery in that aspect. We also decoupled our ventilation and our heating and cooling systems separately so that we were addressing, ventilation, and we were only adding heating and cooling as required by the building. And because we worked so hard on our building envelope side and our energy recovery side, that did not happen very often, which is exactly what we want to see. We did have a very efficient building envelope on the opaque side, and we did have a lot of glass, but it was very efficient glass, so not too much worries about that. Our roof was highly insulated, as were our walls. And overall, this meant that we're achieving a roughly 50% reduction over the National Energy Code for Buildings, the 2017 version, which is very, very significant for this type of project. The second example we wanted to bring to your attention is a retrofit project. So this one is a retrofit and addition. And this is a police station that's located in Southern Ontario that contains offices, detention areas, training rooms. That they needed to make some to the 3-story.
Are we losing Alexandra here? Okay.
Yeah.
You can hear me though. You can hear me, I mean, still?
Yeah.
I can hear you.
Oh, she's back.
Okay. All right, you're back. You're back. We'll give you another go, and if not, Alexandra, I can take over from here.
Oh, okay. I'll stop my video. I think that should make
Okay.
sense.
Probably, yeah. Can you repeat the slide? I think it started glitching on this slide, Alexandra. Thank you.
Yeah, absolutely. So this is the second case study that we were hoping to speak to, and this is a police station that's located in Southern Ontario, and it contained offices, detention areas, training rooms, and other support spaces such as storage areas for the occupants. The existing building was 1 story, and it was coming to the end of its useful life and was looking to have quite a extensive refit, not only motivated by energy, but also by the changing requirements of the occupants in the building and just the different use types that they had to accommodate. The project also contained a 3-story addition. So the town had recently mandated that it wanted to see net zero carbon for all corporate buildings. So we conducted a study for this particular facility to figure out how it could get there. We had quite a few challenges to address decarbonization at this particular building, mainly figuring out what the optimal approach to achieving net zero is. What does that look like in terms of our best value for the money? Of course, this is a municipal facility. We want to make sure that we're spending the tax dollars in the optimal way to achieve the outcomes that have to be done. And also a very big part of that was of the challenge for this building is how do we do this extensive renovation while supporting the services that this building has to continue to deliver? So what do we do with the occupants during the extensive refit? What was the solution for this building? So our solution really focused on electrification of the heating system. Again, back to the heat pumps. So the primary solution was the introduction of air-to-water heat pumps in the project that allowed heating hot water to be distributed throughout the building. We are looking to replace the boilers, which are currently gas-fired and at the end of their useful life, with these air-to-water heat pumps to provide essentially the same use. Overcladding or improving the building envelope is also a key component of this. Looking at the rendering that we have in the energy model, you can see that we have a lot of roof. A lot of that roof is existing, and it was not performing at a level that would meet current code, and certainly not on a level that would have met our decarbonization goals. So some of those strategies have been carried through, and they're looking to implement better windows, better walls, as well as a better roof. And this building, in combination with the efficient mechanical system and the improved building envelope, is also looking to add renewable energy generation on site. And the last case study that we wanted to talk about is a federal building that's located in the National Capital Region. So the federal government has been sort of spearheading this push towards decarbonization for a lot of its federal facilities. It's been doing decarbonization studies, I don't know, Eric, probably for almost a decade now that we've been involved with. So they were a little bit ahead of the pack, so to say. So this particular building was a building that they occupied. It was built in the 1960s. It was 13 stories. And the tenant, which is the federal government, it mandated that they must reach net zero emissions by 2030 for this building because they are occupying it. So this was quite a challenge. This building was not very well performing to begin with, built in the 60s and not really touched since then for the most part. So the building envelope was really lacking. The mechanical systems were out of date and certainly not in line with where we need them to be for decarbonization. But all the other challenges that we frequently see, such as, how do we make this make sense for the budget? What do we do with the occupants? How do we best implement these systems? All of this arose. And ask to go to the next slide, please. So for this project, we actually took a look at several different options. So I think when I was talking about the process for decarbonization, I mentioned that the report as the final deliverable for the study, it may look like one strategy, or it may look like multiple strategies depending on the client's desire. So in this case, the client wanted to see several approaches to carbon reduction, and that looked like having a cost neutral carbon reduction strategy, a maximum GHG reduction strategy, or sort of the sky's the limit one, no budget constraints, as well as an optimized GHG reduction strategy. So this is, I like to think of it of what would you do if this was your building and you had the constraints on the funding that everyone has, as well as a tailored reduction strategy. So the tailored reduction strategy is really what the building should be moving forward with based on the previous 3 strategies and sort of balancing the different pros and cons of each. So we evaluated the different strategies and the impacts that they had on all of the metrics that we had previously discussed. So our EEUI, our energy use intensity, our TEDI, and our GHGI. And you can see that all of the scenarios, so scenario 1, 2, 3, and 4, they had very similar results for our GHGI actually, but they had significantly different impacts on our costs. So that was very important to consider as we were proposing our tailored strategy for this particular project.
And I think an important comment here, Alexandra, too, right, is that under all of these scenarios, you are not seeing net zero GHGI, right? So again, pointing to that triangle, that pyramid, and the fact that even when you deploy all of these strategies, there may still be emission sources that are difficult to remove.
Absolutely. And this is something that you will see for most of the projects out there. It is very challenging to achieve absolute carbon neutrality with the constrained site conditions that we frequently have for existing buildings. Okay, and then talking about how did we evaluate these scenarios? So as I mentioned, there were 4 scenarios and they sort of had different goals within them. And the metric that we use to evaluate them is the 40-year life cycle cost. So this life cycle cost included everything from our initial cost. So how much is it costing to buy this equipment, install this equipment to start with on day 1? It included our energy cost as well as carbon cost. So it's very important to highlight that carbon cost is also coming into this metric when we're calculating our net present value, because that will look like different things for different systems that we're using. This also included our equipment replacement costs. So what does it look like for the different proposals that we have, as well as our operation and maintenance cost. So we really evaluated all of these based on the NPV. And as I mentioned, the strategy that we put forward as a recommendation to the client was our tailored GHG reduction strategy, which was the best of both worlds. That achieved significant GHG reductions, but you can also see here, these have been changed a little bit, but you can see here that it did achieve the lowest total cost, despite actually having the same initial cost as our cost neutral solution. So that's very good to see, because you really see the effect of our energy, carbon, replacement, and operation costs coming into that equation. And this is what the decarbonization approach looks like when it's tailored. So when it's a tailored approach, what we typically see is that the approach and the different phases of the approach are aligning with our capital plan. I think I mentioned earlier in the presentation, things you can look at are, when is your equipment coming to end of life? When is your building envelope coming up for renewal? At those points of intervention, you will have buckets of money that's already available and allocated to some form of capital investment. And it's important to align those with any decarbonization strategies that you may have, just to build that business case, going back to making this more palatable for the municipality, for the particular project, and any other stakeholders. So for this project, that phased approach looked like sort of 3 distinct steps. The first one being an energy reduction in the short term, partial fuel switching in the medium term, as well as a full deep energy retrofit and a full fuel switch later down the line, when that better aligned with their capital planning. So the other approach we sometimes do see, but this is a little bit more rare, I will have to say, is an aggressive decarbonization approach. So this is when there's an opportunity and the funds available to implement all of the recommended measures at a single point in time. So you can see here, as compared to the other graph that we showed, this is actually the best in terms of reducing the total carbon over the life of the project. And you tend to actually get a better, a more efficient building than you would have by implementing these measures in a phased approach. And the reason for that is you really get the opportunity to right size a lot of the equipment that you're putting in. You're taking advantage of, your building envelope improvement, infiltration reduction, ventilation reduction, and so on. And then you can have responsive equipment and sizing based on that, and that really results in a more efficient.
Great. So thank you, Alexandra, for that deep dive. I'm going to spend a few minutes here talking about barriers and talking about some funding opportunities, and then we'll turn it over to any questions. I see there's a few that have come in as we've been speaking, so we're going to address those shortly. So let's talk about some barriers. Let's be realistic, right? We're talking about local government, we're talking about municipalities. The biggest barrier, of course, is financial. So as Alexandra was saying there, it's costly to do these things. Some of these buildings have not been touched in a long time. Unfortunately, I think we all know that it is difficult for the public sector to spend money on its own facilities due to concerns from taxpayers, due to extreme sensitivity around spending those dollars. And I think, there's many reasons for that, but the key thing here is that it can be challenging to both just maintain buildings as they are, but also acquire funding for these very significant retrofits or changes. So I did want to share a little bit because I had a really good conversation with some of the leaders at the town of Whitby yesterday. And if you look at their zero carbon Whitby plan, which is a great plan, you can see that they're looking at all of their corporate assets. And what they've identified is that they need approximately $40 to $60 million in order to be able to actually decarbonize those corporate facilities the way that they believe needs to occur. So 40 to 60 million is not a small amount of money for a community the size of the town of Whitby. But they are also proposing a really innovative solution to this. And they're not quite there yet in terms of funding, but what they are proposing is that they can create this fund reserve where they will start to condense and compile different funding streams. And as they move forward with decarbonizing individual buildings, they're going to basically regenerate that fund through avoided costs, through lower energy bills and energy utilities. And they're going to start actually flowing those savings into this fund to support further reduction. So they're going for a bit of a flywheel effect here. And again, like all investments, the biggest, hardest part of this is getting that seed capital to start that fund. But they're hoping that by using this approach, they will be able to achieve more reductions in the near term by having kind of a self-sustaining, self-replenishing fund. The other problem, which Alexandra spoke to, especially with the EMS or police or other types of services like that, is that a lot of public buildings, we just can't shut them down. We're talking about buildings that serve as warming or cooling centers. Often they're the only place of refuge for members of our community. Some of them are performing really crucial services that they really cannot stop operations. They're operating 24 hours a day. So how do you take a building like that and how do you actually create these changes in real time? And there's a lot of logistical challenges with that, and we will not underscore that, undermine that at all. I mean, really, this is a huge challenge for these buildings. A commercial office building in downtown Toronto is kind of easy. People can work from home. You can maybe find some alternative hoteling arrangements for them, but that's really it. But when you look at something like a police station or a fire station, we don't have a lot of options there in terms of disruption. So we have to be very careful about how this is deployed. And of course, as well, these projects do have noise. They do have construction sounds. They do create traffic challenges. So there are also just impacts to the community overall. The other one that we would be remiss not to mention is that public structures are usually very interesting structures. They're old structures, they're beautiful structures. Some of them are very historic. And so some of these buildings by design have not been changed in a long time. And it would be very difficult to change the aesthetic appearance of them because they have that place in the community is really a touchstone to our history. And I'm showing you here one of my favorites, which is the Stratford City Hall. And just looking at it, right, that's architecture you don't see in Canada very often. And it's a very striking part of the downtown core. So how would we look at a building like that and find ways to decarbonize it that would still keep that appeal, that charm? And that's really important. The other part, and this is my hometown here, which is Peterborough. And you can see here, this is one of the hockey arenas in Peterborough. And this is a twin pad ice facility. And many of you, I'm sure, in your communities have very similar facilities or pools or gyms or whatnot. And these facilities have very different facility needs because they're offering services that a regular building does not offer. So they have different cooling needs, heating needs, balancing those energy draws is just a little bit more complicated because of the structure and how they are used. And finally, one that I think everybody should appreciate, we're talking again 2028, 2030, these timelines are soon. And we already know we are struggling with things like skilled labor, with funding, with equipment, with materials, and there's a competition. And so many of you are peer municipalities, but in a way you are also in competition with each other for access to these sorts of brains, hands, materials, all the things needed to make these changes. So keep that in mind, is that the longer we delay, the more competition there's likely going to be for some of this work, because we just really are at the dawn of a lot of this work, and a lot of those skills don't yet exist in our society, and we need to very quickly change that. I would say, personally speaking, that on the sustainable design side, the challenge used to be money. Just getting the money was the hardest part. Now the challenge is getting the bodies. And I think that's a really important thing to consider here in Ontario. So let's talk. I know one of the questions was about available funding and resources, and this is not an exhaustive list, but we did want to speak to what are some tools, what are some funding sources that might help spur your community or give you a place to start. And one of the strongest, best programs that has been in Canada for a long time is the Federation of Canadian Municipalities. So this is a federal agency entity that is basically sole job is to support communities across Canada in deploying projects and services that are going to help reduce the environmental impact of operations. So the Green Municipal Fund currently has a $1.65 billion endowment from the Government of Canada, which it uses to dole out loans and grants. So if you've not been a recipient of a program from GMF, I would be surprised. I think most communities have accessed this in some way or another, but there is an energy sector. There is energy focused funding for things like the studies that Alexandra described. I'm sure, as she cited, that many fire department stations have been funded through FCM's GMF fund, and this is available to you, and the link to this is at the bottom of the page. Another one is the Green and Inclusive Community Buildings Program. This is a program from Infrastructure Canada. It has a minimum requirement of a 25% energy and carbon reduction for retrofits, but it's really targeted towards these kind of difficult to decarbonize community buildings. And it's there for you as well to look at as an option. I understand that this current funding stream for Ontario has just recently closed, but I expect there will be a future funding stream as well. So you can look at this link and keep that in mind as well. A third one, which is less relevant to municipalities, but is available to them, is that there's also currently this Deep Retrofit Accelerator Initiative, which is a program of Natural Resources Canada. It's really targeted towards residential facilities. So if you think about this one, it's really in the city context, more about community housing, more of those social housing type projects. So this would not be something you could use for a traditional corporate facility like an arena or a city hall or a police station or whatnot. It's really about housing. But if your community is involved in offering housing, this program is currently active and live, and the link is here. And all types of projects it will support are things like these energy audits we described, that business case development we described, basically everything but the capital project itself. So 4 out of the 5 kind of key things it's going to support you with. So do check that out as well if it's relevant to your community, if you do have those sorts of facilities in your portfolio. And in terms of resources, some resources that we access a lot in our work is, of course, the Canadian Green Building Council. The Toronto Atmospheric Fund, or TAF, has done a lot here in Ontario in terms of advancing the science. The Pembina Institute and the City of Toronto, these are places that they offer a lot of wealth of materials and resources on their websites. And the staff there are just excellent thought leaders in this space. So if you are looking for a little guidance or questions, these could be people that might be able to assist you or just offer you some resources as well. So in summary, I'm going to close here. But again, I think the point we want you to leave here today, other than heat pumps, which you absolutely should remember, is that existing building decarbonization is really critical for us to meet our climate goals that we've all established from the federal to the local level. Municipal corporate buildings are really a great place to start. They're very high priority for immediate action. And we've outlined for you today how you could think about starting that process if you have not done so before. And of course, the most important part is there is funding available to you. And we would encourage you to look at some of those sources. And, that's how projects get started and how we start to create this change is through a little bit of help from outside. So those resources are there and they're at your disposal. So please do check those out. And the final thing I'm going to say before we quit today and I go to the questions is status quo is a conscious decision. So what we mean by that is doing things the way we've always done them is not free. It costs you things. And I think if you saw the case study that Alexandra presented, the status quo was the most expensive because we're looking at increasing energy prices, a world where carbon pricing is in effect. We're looking at equipment that is shifting. So even just replacing things we have now, those technologies may not continue to be offered in the future. So I think, again, just keep in mind that it's not like we're looking at a net plus or a net new cost for these things. The status quo is not free. It needs to be considered and compared for all of these options. And that's something that our councils, our elected officials need to understand as well, is that the question isn't between doing nothing and doing something. The question is between doing just repeating the same process and approach and maybe perhaps errors we've made in the past, or considering different alternatives that offer better value. And with that, I'm going to stop presenting my screen and we'll open up to the floor to some questions. Now, I do see that we have some questions in the list. Amin, did you want to identify which of those we'd want to address here while we are together?
No, if you would like, if you prefer to answer them on your own and read them out on your own, that's fine.
Sure.
I'm just gonna keep track of time. We have ample time, I see.
Yeah, so we'll go through these. So I know there's a couple of logistical questions. So the main question that a couple of people have asked is whether the slides will be shared today. And so as Amin mentioned at the outset, this recording is going to appear on the MEA website. So you will have access to that after today. And I know some of you weren't able to stay for the full time. So hopefully you're hearing me say this as you watch the recording and catch up on what you missed. Going back to another question, there was a question here to Alexandra about building, massing, and orientation. Could you just describe, Alexandra, in a bit more detail what you meant by that in terms of as a carbon reduction strategy?
Absolutely. So we are very much in a heating dominated climate in Canada, regardless of your location. It may vary a little bit, but still very much heating dominated. So any opportunity we have to take advantage of passive solar load that we can use in our building to offset that heating load is a fantastic opportunity. That may look like orienting a large portion of your building towards the south side, which receives the most solar radiation throughout the year, if possible. So that's really where we are looking to optimize the massing.
And again, even in terms of new construction, if there's shade in existing areas, just looking at how that configuration will be protected long-term versus neighboring development, I think is all part of that, what Alexandra is suggesting there. There's a question from Edwin here as well, Alexandra, where he's pointing out that in the fire hall example, he's pointing to these very large glazed overhead doors, which are, a fixture of fire departments. And he's rightly pointing to the fact that, as you've said, glass and glazing is not great for overall energy use. So could you describe a little bit in terms of how that concern was balanced for that project or addressing that point that he's making?
Yeah, absolutely. And that is a fair point. That is something that was a challenge on the particular project. So we addressed that in several ways. Essentially, what it came down to is the rest of the building efficiency had to pick up sort of the to compensate for the penalty that we were getting from the heat loss through those doors. And it meant that we had a all-electric heating system for the administrative portion of the building with extensive energy recovery. We also had radiant tube heaters for the actual bay itself. So that means that those were more efficient than traditional gas-fired equipment. And we also had a lower heating set point for the bay. It was 15 degrees Celsius as compared to a higher like 20, 21 point for a typical heated space.
And we see those same challenges for things like transit yards or bus facilities, where again, it's like you have the challenge of how is the space functional for these very large vehicles that need to go in and out all the time, while still trying to conserve energy where you can. But yeah, definitely a great point. And thank you, Edwin, for pointing that out. There's a question here from Adam as well, where he's asking, I think Adam must be on the consulting side because he's asking, when you're communicating phased versus aggressive decarbonization approaches to clients, are clients receptive to the idea of this total avoided emissions metric? Do they care about that overall avoidance, or is it really more about the percentage goal they're aiming for? And Alexandra, I mean, this is, I'm sure, a conversation you've had. Would you have any feedback for Adam on that?
Absolutely. So I think they recognize the benefit of the overall larger carbon reduction. However, I would say that does not play a role in their decision making. It is really, are we hitting that overall net zero goal of % reduction by a certain date? And are we meeting our budgetary constraints? That really comes down to that.
And Adam, you've corrected me. Apologies for tagging you with the consultant brush. So Adam is with the region of Peel. But thank you for the question, Adam. Hopefully that addressed it. So Alex is asking, Alexander, this is a really good question. So Alex is paying attention during that pyramid slide. Where he's asking is, how common is it when electrical capacity of retrofitted buildings has to be increased due to fuel switching from natural gas to electricity? So this is the concern, right? Is if we're moving to electric vehicles, if we're moving to electrified systems, is that just increasing the draw? And Alexander, what are your thoughts on that one?
Absolutely. And that is I would say, one of the largest challenges we are finding on existing buildings. If the only measure that they are doing is electrifying their building, they will absolutely have to increase their electrical capacity. And this is exactly why we recommend other measures in conjunction with that. So reducing your load so that you don't have to upsize your electric capacity, or maybe not as much, by improving your building envelope, reducing infiltration, and doing some of those other measures that we talked about. But frequently, it will come down to that, and that can be a very costly pursuit.
And I think to your point, the key thing, we don't want water flowing into a leaky bucket here, right? So we want to make sure that the energy that goes in is being used and not lost because of these inefficient buildings. But I think, yeah, it's very true to your point, Alex, that we are moving into a reality where electricity supply is going to become more and more important. And I think we look at provinces like British Columbia, where they're already further down that path, and that supply is definitely an important consideration. And having cheap, accessible electricity is going to enhance and expedite, I think, this decarbonization process. So we all do need a better performing grid, and one that is full of clean sources across our province. Anil is asking a question about biofuel as an energy source. And I would say that's non-traditional. I would say mostly, Anil, the challenge there is that's like very much a logistics challenge, is that where biofuels are often available is rarely where buildings are able to make use of them. And they do require, again, I would call a lot of that same infrastructure around existing fuels. So that one, it's a rare one for me. I know it does have some applications, especially when you have some like co-located facilities. But Alexandra, I don't think I've ever seen a biofuel project in kind of a more urban environment. Is that one that you're familiar with?
I would agree with you. It's something that we see in more remote communities, and logistics is a challenge. The other point I wanted to add to that is making the choice to pursue biofuel as your strategy is less preferable, because you're looking at sort of incrementality and you're relying on that consistent fuel source, which may not be a reality. And it's making a choice not to go with a electrified system, which is really the preference.
You're locking yourself into something. And I think, again, I think about hydrogen too as a fuel source, is that, there just isn't the infrastructure at the scale that I think gives us kind of safety, in the sense that those options will continue to be available and affordable long-term, outside of, again, I think those unique considerations where you're very co-located to biofuel options. So Alexander, Adam has another question, and I think we're getting deep into the fire hall, which I love. And so he's asking, you mentioned the lower set point temperature in the bay of 15 degrees versus 20. And he's asking, did you consider, or is there a break point where that temperature is too low, where an energy recovery doesn't make sense, economic sense? So he's looking at that delta in terms of heating and cooling and what the economics are there. Do you have a comment for Adam on that one?
We really haven't seen well, first of all, I would say two things. So number one, it doesn't always come with a lower, it doesn't have a payback. So sometimes capital costs when implementing energy recovery is not a factor. We just decide that this is a strategy that we're doing because we recognize that in terms of energy and carbon reduction, this is what we have to do. And we haven't really seen that cutoff point. Perhaps if we go lower than that, maybe that would come up. but we really haven't seen that to be an issue. One item that I wanted to bring up for energy recovery is if you have solar wall preheat, sometimes that starts to sort of play against each other. You don't want to have energy recovery and a solar wall preheat necessarily in the same system, just because then you're sort of spending money twice for essentially the same goal.
So you haven't done one that's below 15 degrees as a set point yet. Okay. So in theory, there is one, but we haven't actually in practice explored the range there where that might become a factor. Great. Edwin has a question regarding TEDI, and he's asking, does this not capture cooling energy? Are there ways to capture the increased need for cooling? And before Alexandra mentions this or answers this question, I think Edwin's onto something really important here too. Ontario is a heating dominated climate, but as we all know, because of this very topic we're discussing, which is carbon, our climate is shifting and we are going to have increased cooling loads in the future. And if you've noticed those trends, it's that, yes, we're going to see more days above zero and more days where cooling for extreme heat is a challenge. So Edwin has a good question here on TEDI or TEDI. Alexander, do you want to address that one?
Yeah, that's a great question. So absolutely, TEDI is only covering heating. And the reason for that is because we are very much heating dominated in Canada. However, certain projects have started to set cooling energy demand intensity or SETI targets. And that is typically for buildings that have a traditionally much higher cooling demand, such as laboratories, computer spaces, sort of higher occupancy spaces, such as lecture rooms and auditoriums. So there is a push and a recognition that cooling does become an important factor as well. And that's sort of a project by project basis.
So there's one more question, which I'm going to say is probably the final one we'll have time for. But the question is, it looks like there's a project here for a net zero e-bus facility. And I'm reading that it's impossible to achieve net zero because of the electricity demand. So asking for some guidance or advice on what is a reasonable target. I don't know, Alexander, do you have thoughts on that? But I can sympathize here in terms of the power draw that these buses must be drawing from the electrical grid.
Oh, absolutely. And it's not only the buses, in those facilities, you typically have a lot of slab heating as well. That plays a big part in the net zero energy. It's absolutely a target. What I would say, we still want to make sure that we have an energy efficient building. So you can set those targets for the conditioned spaces in terms of your EUI, HEDI, and GHGI. And for the whole facility, you will be really relying heavily on renewables on site to get anywhere close to net zero or such as that.
And presumably battery technologies are also going to be part of that solution long-term regarding the on-site renewables. Absolutely.
And technologies, we're sort of hoping that the technology will catch up where our needs need to be. You can look at how solar has evolved over the several decades that we've seen it on the market, and we're hoping to see similar technologies for battery storage.
Excellent. Well, thank you everybody for the questions. Really appreciated that. There were some really deep questions in there, which are always great to see. If you have any further questions that we didn't address, you can feel free to direct them to us, but otherwise I will turn it over to Amin. And thank you once again for sharing an hour and a half with us today. Really appreciated the chance to talk about one of our favorite topics, which are existing buildings. So back to you, Amin.
Thank you. Thanks, Eric and Alexandra. Thank you very much for taking time from your day to share your expertise and knowledge with our members and audience. And also special thanks to Kelly Murphy, the chair of the MEA Climate Change Committee, for coordinating this webinar. And thanks to our audience for sticking around and listening to our webinar. I want to add that we do not provide certificates for continuous educations. We can provide if you can put me as a reference. I mean, Menena, you have my email probably through the e-blast that we've sent. You can put me as a reference if that's needed. But for self-reporting, you can refer to our website. We have a record of all our previous webinars that we've hosted to document that in your self-reporting for PEO purposes or any other organization continuous education purposes. And with that, thank you very much and have a wonderful day. Thank you.